at a time or whatever. It's better than my old camera. It used to conk out right at 1 hour all the time. Yeah.
Quick question about...
Was I in the middle of something?
Oh, I thought we were finished.
That was 6. Okay, good.
Yeah. Well, it kind of...
It's done.
4D is intervals where x... Oh, wait, hang on. 4C, excuse me. All intervals where f of x is continuous. So that one is only going to be where it's solid dots on both sides. You don't want it where it's continuous from the left, continuous from the right, because it says intervals, right? Intervals.
So the one place that we count as continuous, because I think I put brackets on the endpoints. If it's at the endpoints of some defined function, it can do all kind of weird shit in the middle. But I would include the endpoints because they don't even have a chance. But like this guy, I would not include that point because it's definitely not continuous. It's only continuous from below. But the endpoints, I really want you guys to understand, this is a very small point, by the way. I probably wouldn't take points off for this, but I always include endpoints if they're defined there for continuity, because it's not this point's fault that the function doesn't have any values over there. I don't know what it would do over there. Here I know what it does. So screw you, you're not continuous, right? But I'm pretty sure I should have included the endpoints.
Yeah, well, you have like that, but so if your endpoint on the left there is -4, and your other endpoint is -2, and then it drops down, you have an open circle on -2, wouldn't the continuous interval be -4 to -2?
So negative...
I just randomly made up those numbers. They don't correspond.
Oh, okay. All right.
But it goes with the same... Okay, so let's go to the graph then.
Yeah.
1, 2, 3, 4, 5, 6, 7. You got -7. -7 to -3.
Good.
Wouldn't that be your continuous interval on that graph?
Yes, but not including -3.
When would you put in brackets or parentheses again?
If it truly is continuous, and the one place I can understand where you guys would have trouble understanding it, why I include it, is the endpoint. So if this is like -7, I included it. This I definitely would not include, because I didn't say anything about left or right. I just said continuous. Is it continuous at this point?
No.
Desperately, obviously not. That's a jump discontinuity. It is so not continuous.
So you're saying that it just keeps on going, but that's why...
No, I definitely made a point there at -7 to say it stops here. You with me?
Yeah,
I put a point there so it stops.
Instead of a bracket then.
It's a bracket because I always include the endpoints. Because it only makes sense to talk about them from one side, because the function doesn't even exist at all on the other side. So that's a little unfair. But if you didn't put a bracket on, I'm not going to take off 28 points or something crazy. I probably won't take anything off. I'll just say you should put a bracket here. It's a small point. It's a very technical point. But we always include the endpoints when we're talking about continuity if they're defined there. Because otherwise it wouldn't be fair.
Okay.
This guy, I have to talk about below and above, because the function does exist above and below him.
So if it has a hole...
So that's why it's not continuous there. If it had a hole at one of the endpoints, screw the endpoint. It doesn't have a chance.
I don't care about it.
Yeah. But it's just not fair. It doesn't exist over here. What the hell, man? What can I do? I can't even talk about that side. So I only talk about the side I can talk about. So here, what side can I talk about? From below and above, not continuous. So I always talk about what side I can possibly talk about. And that's where the endpoints, if they are filled in, are always included as continuous.
So if we answered that -7 bracket, comma, -3 bracket.
But I'm saying if you did, oh, I see. If you did this, I'm okay.
That's parentheses.
If you did this, tears of joy.
Okay.
If you did this, just straight up tears of pain.
Sorrow.
Because -3 is so desperately obvious that it's not continuous. You cannot include -3. Yeah.
So on that same problem, how come it doesn't have a bracket for 10? Parenthesis 4 and then parenthesis 10.
Oh, just because I was.
So if I put a bracket there, would it still be right?
There should be a bracket.
Okay.
Yeah, I think at that point it just was.
I mean, either if I put it that way, it'd still be right technically.
Yeah, I did that just to show you. Yeah.
Can you do 3C?
I just forgot. But yeah, 10, since it's a filled-in circle. I think originally I wanted to make it an open circle, but then I thought that'd be too much. You should include the 10. Yeah.
Can you do 3C more than one?
You guys with me? That last interval technically should be 4 parenthesis comma 10 brackets.
Bracket, yeah.
But if you don't put a bracket on it, it's not a big deal. That kind of tells me you understand continuity. It's just that the technical thing is not quite there, which is fine. Yeah.
3C.
Oh yeah, so 3C is a little weird.
So you started factoring and then you realized that that's not the way to do it. I factored all the way.
And the thing is, now let me put up here a little bit easier thing to look at. Go with me here for a second. Actually, let me do this. This is not what is called indeterminate. And I'm not sure if I've really taught, I've kind of thrown that word around a little bit. Indeterminate is like 0 over 0, infinity over infinity, 0 to the 0, infinity, well not to the infinity, but infinity minus infinity. We saw one of those earlier, right? I can't say that's 0. We just saw the earlier example. It completely depends on what is in there, the A and the B. It depends on how quickly they go. So these are all indeterminate forms. Those are the ones that have to factor and multiply the conjugate, do all this weird shit. This is completely determinate. Because 1 makes the bottom 0, but it makes the top 3. Right? You with me? 3 over 0. That's going to
0.
Wait,
Does not exist.
as x goes to 1. To be a little more specific, I agree with you. It does not exist in what way? Since that's squared, it doesn't matter if I'm going from above or below. And actually, this is a little bit evil because this is minus 1. But as I go to 1, this goes towards 3, and this goes towards 0, right? So it does not exist, but which infinity does it go to?
Negative.
Positive. No, yeah, positive. Final answer.
I say
I like it. So actually, it does kind of depend on which way, because if you put in there 0.9 squared minus 1, that's going to be greater or less? Less than 0, right? And if I put in there 1.1 squared minus 1, that's going to be greater than 0. So it does depend on which side you're going from. Okay, so that one you could officially say just does not exist because it doesn't even agree on which infinity it's going towards. You with me? Cool. Alright, that was hopefully going to be my easy explanation, but do you see why I don't have to mess with this? I don't have to conjugate, I don't have to factor, because it's determinate. I can actually determine what the answer is. The top doesn't go to 0 or infinity, it goes to 3. So I should be able to figure this out. So the problem that's actually in there, yeah.
So I have 2 questions. One, so if you graph on your calculator, you see 1 going up and 1 going down, so that would always be does not exist. Unless
it's specific about from
the
below,
plus
above or
minus,
below.
yeah. And then the other one is, I've asked you this a couple times, but I just want to be sure. When it has the little plus or minus, it means when it's a plus number, it's coming from the positive x side of the graph.
And again, I stay away from positive or negative because you could be at negative 18 billion, and from above would still be negative
Okay,
numbers.
so
it just means
the
from
y.
above.
It says above.
Do I have a graph from above or from below?
So below would be coming.
So if I'm talking about this point here, these are all negative, even though it's coming up from above.
You're correct.
From below. So from below, the limit would be this. From above, the limit would be whatever that is.
Even if it's coming like this, it's still above.
No. This is where it's important. And when we're talking about limit as x goes to something, that's x we're talking about, right? So it's completely about x, left and right. Up and down has not a damn thing to do with it. That's going to be my answer. It's going to be, so if I'm going like this, negative 1, this is 3, and negative 2. So the limit as x goes to negative 1 from above would be here, negative 2. I don't care what this thing can be going, all kinds of weird crap. I'm not talking about from above. I'm talking about from above, like this, from the right. Maybe that's even better. From the right, from the left. Because I have problems with left and right, so I don't like that. But and from below, the limit would be 3. Does that make sense?
Yeah. So, but let's say they're all on the negative x side. It's just whatever. Let's say they wanted to come above.
Yeah. See, this is on the negative x side.
Like the functions, like everything's stopped. It never crossed the y-axis to get to positive. Whatever's closest to the positive x side, would that be from above?
Yes.
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 Does that make sense? Okay.
From the bigger side.
So whatever's closest to the x-axis, or the positive x-axis would be from above. Whatever's closest to the negative x-axis would be from below.
And that's a weird question because you could be completely in the negative. So just think left and right. Are you good with the left and right?
Yeah.
Plus means from the right.
Yeah.
Negative means from the left.
Yeah.
Cool. Yes.
Perfect.
Wait, you still didn't answer my question.
What was your question?
3C.
Oh, yeah, I know. So I got sidetracked there for a second. So limitization goes to 0 from above. So the point from this was, is this actually indeterminate? Do I have to start trying to factor stuff? I kind of made it look like you did. And actually, I think I did. I think you can factor to a point.
No matter what, it still becomes 0 at the bottom, even though after like you cancel it.
Yeah, and what's on the top? -2. Right? So that all depends on, is it going to negative infinity or positive infinity, right? Because this is basically -2 over big. Is it big negative or big positive? That's the question. And one way you can think about it, you guys kind of with me?
That's a big negative, right?
This is not indeterminate. The top is a constant when h is at 0. So I don't have to do any weird shit. I don't have to do, I can't remember now. Did I do any? I started to and then I was like, I'm not even going to. Because you don't need to. When h goes to 0, the top is around negative. It's -2. And here's the funky thing. This is where your study of graphs and pre-calculus helps you out. What kind of graph would this be? What's the end behavior of this? Or actually, at 0, let me try it this way.
It goes like this.
I'm thinking about infinity. I need to think about 0. As h goes towards 0, what's going to happen to this thing? It's going to be like h, and it's going from above, right?
Oh, so it's going to go this small.
So this is going to be positive times negative, right? You guys with me? So as you go to 0, the top is negative. I can't remember what I did on the paper.
Yes.
Negative. And the bottom looks to be negative.
Because of the cubed root, right?
Yeah, it's because the highest power is I.
3.
Right? So
Well, you got to be careful because we're talking about 0. It could be doing anything at 0. Just depends on if it's passing there or if it's passing there. Right? Is it?
Hang on, let him finish the problem, because I want to see if you're matching what you have on the paper here.
Now I'm trying to remember. I don't think it does. And I'm trying to remember the way I look
Yeah,
at
that's
it.
a positive on the.
You have the top as a negative and the bottom as a positive, and you're going to negative infinity.
All right, that's fine. But now I'm trying to show you how to think about it, and I might not have been thinking about it right at the time when I was making the key. If you let h go to 0 down here, I don't know what I was thinking, but yeah, if h goes to 0, then from above, this is a positive number. This goes to nothing, this goes to nothing, and this is a negative. So I don't know what I was thinking about.
Right? I plugged numbers into that, and it told me that it went to positive.
There you go. So this is what a positive. Yeah, this one.
So the key's on.
So here's the positive.
Yeah. Positive infinity.
Why, can you elaborate one more time? Why does it go to positive infinity?
So if you look at the bottom,
Two on top.
as h goes to 0 from above. So what does that mean? What kind of number is h always?
0.
No, it's never 0. H is never 0. It's always positive, right? It's going to 0 from above. So h is positive.
Okay.
This goes to 0. This goes to 0. That's -6, right?
Yeah.
So it looks like the bottom numbers are always, as you get close to 0, it's going to be negative kind of numbers.
So negative.
Yeah, so it should be negative over negative. I really can't remember why I had that as a plus.
So for the top, you just plugged in the 0 and got -2 on top.
Yeah, because the top definitely goes to -2. There's no question. Because I could split that limit up, right?
Yeah,
It's
okay.
basically what I did.
Okay, and then for the bottom, you took an h out.
Yep.
And then when you plug the 0 into the parentheses.
Yeah, let this get close to 0. This is positive.
Like 0.1.
That goes to 0, that goes to 0, and that's always negative.
So the bottom's -2.
Yeah, that's what it looks like to me. Yeah, and that kind of jives. If you graph this thing, it sounds like it's going to positive infinity. Cool.
Wait, so how did you get -2 for the bottom?
Get negative what?
You said the bottom is -2.
That's why I was trying to
Also.
finish it.
Also. It's negative also.
Okay. I'm thinking too
Yeah.
Well, I'm not sure if you already did this. I might have missed it. The 2b, or not to be. Let's see. 2b is the inverse function of just the function of x. It's like
The function of f.
I'm sorry, function of x.
Yeah, so that's a semi-trick question because it's a question of I didn't say is it invertible or not. I just said find the inverse function. So the correct answer would be you can't because, as we already said, it's even, isn't it? Isn't it an even function? Which means whatever is on this side, it's the same on that side. That pretty much means any even function can't be truly invertible unless you restrict its domain.
So it's even because of that x squared.
Yeah, we know it's even symmetry. We talked about that earlier, but the big deal there is it's not invertible. It's not going to pass the horizontal line test, so you can't find the inverse function. And also, when you start to go through it, I think I went through it a little bit
Yeah, you started.
because it's before we actually talked about symmetry. But right there, when I'm trying to solve for y, it's going to be a plus or minus. So right there, I know it's not. There's no inverse function. That's another way to check if something's invertible to see if I can solve for y explicitly, and I can't. I get two options. That means it's not invertible. Yeah.
For the one we just did, let's say it said as h approaches 0 from the left side of the whip, the answer would just be negative over positive? Or-
Yeah, because then that would have been negative values times negative. Then it would have been negative over positive.
Okay, alright.
No, I don't think that's what I
No, I
was
just want to
thinking.
make sure I understood.
Yeah, you're fine. I think that one I knew I'd get a question on and I would do it. I just can't remember why I thought it was positive on the bottom. But now we all know it's negative on the bottom. Okay.
Are we going to be all right just plugging numbers into that one, table form, on that column right behind you? Or do you want us to do a plus minus?
That's fine. I didn't specify how to do this. That's better than just trying to attack this like a normal one. I want you to realize you don't have to do that. You can actually just, yeah. But I mean, like on number 3A or 3B, I really don't want to see a table because you can do something to it. You can work with it. You can factor it. The thing about 3A, what is it about 3A? Yeah, see, 3A is one of those that there's no problem at all with the limit number, so you just plug it in. Part of me wants to say I did, but I don't know now if I did it right. Listen.
Oh, is this you just divide by the lowest? Never mind. It's just divide by the lowest. That's exactly mine.
All 3B is a factoring problem. The most direct way to try to do a limit where it's indeterminate is to factor and kill the problem. And in fact, that's what always happens with, it's not a factoring situation really, but when I'm doing derivatives, it's the way the process is set up is I should almost always be able to kill that h. Kill the problem. The problem there is h goes to 0, it's on the bottom, it sucks.
You're talking B or C?
3b. On 3b, a goes to -6 makes the top and the bottom 0. What does that mean about a polynomial? If a polynomial is 0 somewhere, then x minus that number should almost definitely be a factor of that thing. Are you with me? It's one little thing that came out of pre-calc. It's a synthesis of a few things, but does that make sense? If a polynomial is 0 for some input, then you should be able to factor that polynomial as x minus that number times something. So if they both have a problem, if the top polynomial and the bottom polynomial go to 0 at that input, that's telling me I should be able to factor it and kill the problem. And when I factor it, that's where I got the x plus 6 and the x plus 6. They went away, and then I'm allowed to plug a -6 in. because I've killed my
Oh,
problem.
because you factor it.
Totally. Right? And of course, the next step is, do you remember how to factor a cube? Kind of problem. Right? This is where people might resort to tables, which I have to take some points off for because I want you to be able to factor. This is a very basic skill. So one thing to take away from that is there will be quite a few factoring related problems on here. Yeah.
You already went over this one, but I kind of was confused on it. It's number 12. And how would you make the table again? Like, I know you used 0.1 or 0.01. Like, what did you...
Yeah, really, how do we, like back when we were talking about going to 2, the limit as x goes to 2, or something, we would make a table like this, 1.1, 1.4, 1.5, 1.9, 1.99, right? We're going to 2. What we're really doing was 2 minus 0.9, 2 minus 0.5, 2 minus 0.1. This is the way to approach 2 from below, is to make the distance you are smaller and smaller. This is actually capturing the whole h goes to 0 thing in table form. You kind of with me? The input that I'm using is getting closer and closer to the one that I want to know something about. That's the whole idea of limit as h goes to 0, making that distance disappear. You with me? So if I have a pi over 2, well then I just make my table pi over 2 minus 0.1, pi over 2 minus 0.01. From the other side it would be pi over 2 plus 0.1, pi over 2 plus 0.01. So then I'm getting closer and closer from both sides. So I can try to see where they're going.
I thought you said that doesn't work. Remember you were talking about it.
So it's just like in algebra when we taught you how to solve systems of equations by graphing. And then we said sometimes this is not the best way to do it. We still gave problems on a test that were designed to not have the problems we discussed. Just to make sure that you can still do it. So this has important skills in it that we have to know, we have to understand. It's a very concrete application of these limits. I want to give you problems. But then I said, I don't want to solve every system of equations graphically. Shit. Right? The answer could be square root of 7, comma, 1.888143. I'm not going to find that, especially with my graphs. I could barely find 1, comma 2. So that's why we've developed more algebraic ways, more calculus ways, but more algebraic ways to actually do this. To get what the real derivative was, theoretically, not experimentally. This is like an experiment. Over and over, trying to see a pattern. When we do the limit as h goes to 0, that kind of stuff, that's theoretical. I'm not actually plugging anything in. I'm saying what it would go to. I'm getting the exact answer instead of approximations to try to see a pattern. Is that semi-understood? We had that bit of discussion a while back, and I was hoping that it made sense then. About why this method definitely doesn't work. I don't want to do this forever. Dear God. It's almost good that this doesn't work really well for some things. So we move on. We make better ways to do it. Yeah.
Okay, so still number 12, I take cosine of x over 2x minus pi and put that in my calculator, right? And then I take, so I got the 1.4708, and I do like a second trace of upper value, and plug in 1.47 whatever, but I don't get the same answer key. What could I be messing up?
Did you put it in your calculator as cosine x divided by parentheses?
Yep.
Are you in radians?
Maybe not, probably not.
Maybe.
Down in degree, that's what it is. Got it.
That's the main thing to check when you're dealing with trig functions. So I think I told my class I did a whole test in the wrong mode. And all the answers were such that you couldn't catch it. Like normally you'll have an answer he was negative 800 feet above, and that doesn't make any sense. It must be the wrong thing. None of them came out to really something, and he gave me like an F. And I'm like, I had all the freaking concepts right. It's too bad, Joe. You have to check yourself. So I'm still a little bitter about it. So be really careful about mode. And basically now I just keep that sucker in radians almost all the time until you see a problem that has degrees in it. I mean, the radians is a real number. It should always work unless something's based on degrees somehow. You don't have to stay here, by the way. If you're ready, you can head out. I'm not gonna keep track of your names as you leave. If you don't make an A, then I'm giving you an F.
For a 2B,
Yeah.
the F is not able to have an inverse because it doesn't pass the horizontal line first? Okay.
And you saw it as I started to try to do it.
Yeah.
I got to a point where I was going to end up with y equals plus or minus. That's an automatic no for inverse function. It has to have one output for every input, vice versa. Oh, yeah.
Hey, I wasn't really sure. I still, like, you taught it as best as you could. I didn't really understand 3C. I know there's a positive infinity, but I don't know how. When you plug in a zero, or like a .0000001,
Yeah?
it doesn't go to infinity. It goes to the -2, right?
What do you mean it goes to -2?
Because -2 is on top, and you said 0.
I don't care. What's on the bottom, though? I mean, if the bottom